All right, so we're going to look at our third standard here, which looks at exponent properties with quotients. So we've looked at what we do when we multiply with exponents. Here we're going to look at what we do when we divide, right? So our first rule basically says that if we have the same bases, we're simply going to subtract the exponents. Okay, just want to subtract the exponents. So if I have something like n to the sixth, and I'm dividing by, and remember a lot of times with division we use a fraction bar. Let's say at n to the third, right? My rule is to subtract those exponents, right? I get something like n to the third power in that case, okay? And if we think about that, right, n to the sixth is 6 n's over n to the third, right? So essentially I can cancel out 3 from both sides, right? So I'm subtracting those 3 out of there. So we get n to the third, okay? So we just want to subtract our exponents when the bases are the same. All right, so let's look at some examples down here. Zoom in here a little bit. Okay, we've got x to the fifth over x to the eighth. Now, there's a couple ways you could approach this. Let me draw that a little better for you. So I could think of this as subtract, so that's x to the negative third, right? 5 minus 8 is negative 3. Again, we want to rewrite that with positive exponents like that. The other way you could think about it is I've got 5 of them on top, 8 of them on bottom. So if I cancel out 5, that would leave me with 3 there, right? So I've gotten rid of all my x to the fifths. So I just have 1 in the numerator. I still have 3 x's in the denominator. Okay, so sometimes you can skip that writing out the negative 3 step and just think about it like that and think, well, there's still going to be 3 x's on the bottom, x to the third power. Okay, so 1 over x to the third. All right. Look at our second problem there. Kind of similar idea. X to the seventh over x to the ninth. Again, our rule is to subtract exponents. So 7 minus 9 is negative 2, which is 1 over x squared. Okay, we're going to think about I'm getting rid of all 7 of those. If I get rid of 7 of them, that leaves me 2 left. So that's where our 1 over x to the squared comes from. Okay, our third one. Now this one sometimes can be a little tricky because we don't sometimes think that, well, x on the bottom there, right? While it doesn't have an exponent, it does. It's just invisibles, right? One of those invisible ones that we have in math. So I got x to the eighth divided by x to the first. Again, our rule is subtract exponents, right? It would be x to the seventh power, x to the seventh. All right. X to the negative fifth over x to the seventh. All right. And again, our rule is subtract. So negative 5 minus 7 is negative 12. Again, if I make that positive 12, I've got to move it to the denominator. So it'd be 1 over x to the 12th power. All right. So those are all like level 1, level 2 questions. You're just applying the rules, making sure you understand the rules. Okay. Here we add just a little bit to it. All right. Got some coefficients going on, right? I've got an 8x to the 11th and a negative 16x to the 4th. So we just kind of want to think of this as 2 separate things going on. Okay. And you don't have to necessarily write this out, but this is just kind of your thought process here. So we're multiplying those 2 things together. So 8 over negative 16 is just negative 1/2. Okay. And again, our rule is subtract exponents. So x to the 11th over x to the 4th is going to be x to the 7th. Right, and you have more exponents in the numerator, so it stays in the numerator. Right, and the denominator would just be 1. And if I combine those, I'd have negative x to the 7th power over 2. Okay, so just deal with the coefficients separately. Use your rule for quotients of exponents or division of exponents with the variable part. And then just put it all together at the end. Okay. All right. So that would be an example of like a level 3 question. Make sure I'm not missing one over there. My screen. There we go. And then this one, what does y equal in this case? So x to the y power over x to the 7. Well, I know I'm dividing, right? So whatever y is when I take away 7, right? That's going to be equal to x to the 14th, right? So basically y minus 7 has to equal 14. Okay. If I had 7 on both sides, y would be equal to 21, right? 21 minus 7 would be 14. Okay. That'd be like your level 4 type question there. All right. So quotient property, right? If we're dividing same bases with exponents, we subtract those exponents. All right. And then we've got the power of a quotient property is our last standard here. Right? It says attach the blank to both the numerator and the denominator, typically when parentheses are involved. So that's going to be the exponent or the power. Okay. So let's say I had something like in parentheses, I had 2 over 3 squared. I'm going to attach the exponent to both the numerator and the denominator. So that's going to be 2 squared over 3 squared. Okay. Or I might have something like n squared over 4. I did that to the third power, right? So I do n squared to the third power. And again, our rule there, since it's power of a power, is we multiply. So that'd be n to the 6th over 4 to the third, right? So we're attaching that exponent to both the numerator and the denominator. And I could simplify that down to n over 6 over 64, okay? All right, so similar to what we've done before, it's just this time we typically have a fraction going on or some sort of division, right? We just want to attach that exponent, multiply that exponent by both the exponent in the numerator and the exponent in the denominator, right? And remember, when a number doesn't have an exponent showing, it means it's to the first power, right? So 2 to the first, 1 times 2 is 2, so we get 2 squared. 3 to the first, 1 times 2 is 2, we get 3 squared there, okay? Again, we can simplify that down, all right? So let's look at some more problems here. Let me zoom in a little bit. So I got x to the 4th times x to the 3rd over x squared. So if I simplify that out, right, add my exponents, that'd be x to the 7th over x squared, right? And my rule is subtract those, so x to the 5th, right? If you wanted to, right, you could cancel the x squared out and take 2 out of that and make that x squared times x to the 3rd and get x to the 5th that way as well, right? It kind of just depends on which way you want to approach it, okay? All right, my second one there, x to the negative 2nd power times x to the 5th. Well, that's going to give me, again, add your exponents, x to the 3rd power over x to the negative 8th, right? And my rule is with division, I subtract my exponents. So 3 minus negative 8 is 11. So x to the 11th power on that one. Okay. All right, my next one here. So we've got some parentheses going on, so we got to get rid of those parentheses first. Okay. So again, 3 is 3 to the 1st power. So I'm gonna distribute or give that exponent to each one. So 3 to the 1st squared, right? Multiply your exponents. Power of power would be 3 to the 2nd. X to the 5th squared. Again, multiply your exponents would be x to the 10th times 4x squared, right? And remember, all of this is just multiplication, right? That means 4 times. So we can use those properties, use the commutative property to move some things around. So I want to group together constants, those coefficients, and then group together the exponents with the variables with the exponents. Okay, and then start simplifying. So 3 squared is 9. 9 times 4 would be 36. Okay, and there my rule is add exponents. X to the 10th times x squared would be x to the 12th. So 36 x to the 12th on that one. Okay, next one here. Okay, similar idea. So we've got to get rid of parentheses first. So we're going to take each of those exponents times negative 3. So I'd have 2 to the negative 3rd power. Okay, and then I'd have x to the negative 6th times 4x to the 5th, right? 2 to the negative 3rd would be 1/8, right? 1 over 2 to the 3rd power. Make that positive and put it in the denominator, which is 1/8, so times 4. So again, I'm grouping together my coefficients, my numbers, my constants. And then I've got x to the negative 6th times x to the 5th. Okay. If I simplify all that, 1/8 times 4 would be 4/8. 4/8 is a half. And that would be x to the negative first. Again, add your exponents there. Okay, and if I make that positive 1, I've got to move it into the denominator. So that would be 1 over 2x to the first power. And again, we don't need to put to the first power. Just write it like that. So 1 over 2x. Okay, so again, just get rid of your parentheses, right? Distribute that exponent with multiplication. Put your numbers together, put your x's together, start simplifying using your rules, put it all back together at the end. Okay. All right, this next one, that's where we want to take this and we want to take this squared and we want to multiply by every one of my exponents I have in there. And remember that 3 down there, that's 3 to the first power. So I've got m to the third squared, so that's m to the sixth. Again, power of a power, we multiply. Okay, 3 to the first squared would be 3 squared. And then m negative 4 times 2 would be negative 8. Okay, now we need to start simplifying, right? Okay, so 6 minus negative 8. I'm going to deal with my m's first, right? So we're dividing it, so our rule is subtract. So 6 minus negative 8 would be 14. So I've got m to the 14th. Okay, and then on the bottom, I've got 3 squared, which is 9. So I'm going to put n to the 14th on top, 9 on the bottom, like so. All right. All right, this next one here. Okay, it might be helpful to kind of, whenever I have a fraction times something that's not a fraction, I like to write it over 1 just because visually for me it helps my brain kind of line things up. So let's just start putting parts together here. So I've got negative 2, okay, as a coefficient and 4 as a coefficient. So let's multiply those. So that's going to be negative 8. Okay, I've got x to the 4th times x to the negative 9th. Right, so my rule is, since I'm multiplying, is to add those exponents. So x to the negative 5th. And then y to the 3rd I don't do anything with. Okay, and on the bottom right now I have 2y to the negative 7th. Okay, now we're not done yet. Okay, let's deal with our coefficients here. So negative 8 over 2, that would become negative 4, right, if I simplify that. Okay, x to the negative 5th, I'm just going to leave as negative. I always want to deal with my negatives last. And then my y, I've got y to the 3rd over y to the negative 7th. Again, my rule is subtract, since I'm dividing, subtract those exponents. 3 minus negative 7 is 10. Okay. Right? So now I don't have anything left in my denominator. Okay. Now I've got to take a look and see if I've got to move anything with negative exponents, right? So I've got that x to the negative 5th there I've got to deal with. Okay. So negative 4 stays the same. Y to the 10th stays the same. My x to the negative 5th becomes positive 5, and I move it into the denominator. So I've got negative 4y to the 10th power over x to the 5th. Okay. Again, I would recommend get it all down like this before you start moving things numerator, denominator. Kind of save that for your last step, because sometimes you'll get rid of the negative and then it just creates extra work for you. So simplify where you can, right? Kind of separate it into its individual parts then. So I, dealt with the coefficients, then I dealt with the x, then I dealt with the y's, and then see if you have any negative exponents going on that you need to change around. Okay. And we've got this one here, yeah. So x to the 5th over 2x to the negative 7th to the negative 2nd power. Okay. So again, we want to take that exponent and multiply it by all of the exponents in the entire problem. All right. So we've got x to the 5th to the negative 2nd would be x to the negative 10th. Power of a power, we multiply. Okay. Remember, this is 2 to the 1st. So we make that 2 to the negative 2nd, because 1 times negative 2 is negative 2. And then x, negative 7 times negative 2 is 14. Okay, so we've gotten rid of parentheses. All right. Now let's deal with our number first, right? So 2 to the negative 2nd, right? If I make that positive 2nd, I'm going to move it up into the numerator. Okay, like that. And I think I'll just go ahead and square that right away. So you could write 2 squared, but again, 2 squared is mental math. So Again, I make it positive and I flip where it's at in the fraction. So it becomes in the numerator, 2 squared is 4. Okay, and then deal with my x's. So x to the negative 10th over x to the 14th. Right, our rule is to subtract. So negative 10 minus 14 is negative 24. Right? And then when I make x to the negative 24th, if I turn that positive, I would move it into the denominator. So 4 stays the same because it's now positive first power. Right? Remember the negative 24 is only on the x. So we move the x to the denominator, make that exponent positive. So we get 4x to the 24th power. All right, I think that's the last one. Okay, and I am correct. All right. So again, right, follow your rules. The tricky part is kind of breaking it down, right? Don't try and do too much in your head. That's my biggest advice for you here, right? Get rid of parentheses. That's always going to be your first step. Get rid of those parentheses. Use your power of power property there, right? Multiply. Once we get rid of it, then we can start putting equal or put same parts together. Put your numbers together, put your x's, your y's, whatever your variable is going to be, then start following your exponent rules to slowly start simplifying, okay? And again, I would highly recommend anytime you have a negative exponent, try and deal with that last, okay? Right? Try and deal with that last. So wait to get rid of this x to the negative 5th like we did earlier till last. Now this one I dealt with first just because I knew what that was going to be. So we want to try and keep parts together with that. And then once we're done, put it all back together for that, okay? So again, following those exponent rules, power of a quotient, right? The idea that quotient of a power property we subtract, right? When we're multiplying, we add. Power of a power we multiply. Okay?